Hello and welcome to this lecture. Today I am going to discuss the statistics portion of the research methodology that includes the introduction to statistics. So first of all, we would like to discuss some basic concept of statistics, including its historical background and some other aspects of the statistics. And also we discussed how one use this statistics in their research work. So now I start introduction to statistics, and here we sharing my slides. Okay, so first, the basic concept and historical background of statistics. The word statistics has been derived from the Latin word status, Italian word statista, and German term statistic, all of which means political state or government. That is the statistics. The word statistics has been derived from the status, which means political state, and this word has been used from ancient times. And Shakespeare also used the word statistic in his drama Hamlet in 1602. The application of statistics was very limited, but rulers and kings needed information about land, agriculture, commerce, population of their states to assess their military potential, their wealth, taxation, and other aspects of government. Now, these are the some statisticians who contributed more in ancient time, from ancient to modern time. So these are some statisticians, and in which one of the statistician is from India, that is the P.C. Mahalanobis. This is also known as the father of Indian statistics. His contribution in he is the architect of the second five-year plan. He also established the Indian Statistical Service at Kolkata. So now the next is statistics as a meaning and its definition. The word statistics is used to refer as to sense. The plural sense statistics mean numerical facts and record, and as a singular sense statistics used as a subject which we are discussing. The statistics has been defined differently by the different authors, and each author has assigned new limits to the field which should be included in its scope. So there are so many different statisticians who define the statistics at different aspects. So here's some of the definition of the different statisticians. A.L. Bowley, according to A.L. Bowley, who defined the statistics as the statistics may be called the science of counting in one of the department. Statistics may be rightly called the science of average. According to Boddington, statistics is the science of estimates and probabilities. According to Croxton and Cowden, statistics may be defined as the science of collection, presentation, analysis, and interpretation of numerical data from the logical analysis. So there are so many authors who define the statistics on their own way. Some of them, according to Lovett, statistics is the science which deals with the collection, classification, tabulation of numerical facts as the basis of explanation, descriptions, and comparison of phenomena. So these are some of them. R. A. Fisher, it is also known as the father of the modern statistics, and he defined statistics as the science of statistics is essential a branch of applied mathematics and can be regarded as the mathematics applied to observation data. Now, this definition is given by Wallis and Robert. Statistics is the body of methods for making wise decisions in the face of uncertainty. Similarly, W. L. King also has given the definition of statistics. The science of statistics is the method of judging collective numerical social phenomena from the result obtained from the analysis or enumeration or collection of estimates. So if you see all the definition, by all the definition, in all the definition, there are some common facts, and these common facts are that is the statistics which deals the collection of data, classification of data, presentation of data, analysis of data, and interpretation of data. So as a whole, these events or these activities are associated with the statistics. So simply we can define statistics that statistics deal the collection of data, classification of data, presentation of data, analysis of data, and interpretation of data. So this definition is the most commonly used definition in statistics. And the next is scope of statistics. There are so many scopes of and application of statistics. So scope of statistics in the field of industries, and statistics in the field of commerce, agriculture, and statistics also used in economics, educations. So actually there are wide scopes and application of statistics in all over the field of studies. Statistics also used in planning. Statistics also used in medicine. And now there are some limitation of statistics. That is, the statistics is not suitable to study the qualitative phenomena. Statistics is always used for the numerical data. So if you use statistics, it will always take the numerical data. So if you have a qualitative data, that can be converted into numerical data. Now statistics is does not study individual. Study always in study statistics always a study of groups, collections of data, not individuals. It cannot apply on individual object. Now, statistical law are not exact. Statistical observation and statistical laws are not exact. Similarly, the mathematical and physical science, statistics always give the approximate result, while the mathematics and physical science gives the exact result. So, statistics always give the approximation or expected result. Statistics never give you the exact result. Statistics table may be misused. So one should handle statistics very carefully. Statistics is only one of the methods of studying a problem. So these are the limitation. Now we are coming to the main topic of statistics, that is the collections of data. So main statistics start from here, okay, how the data is collected, because this activity is the first and very most important activity of statistics, that is the collection of data. So first we would like to know what is the data. Data, or is its singular form is datum. Data is actually the plural form, and datum is singular form. So data is defined as any information in terms of numbers, measurements, observation, and descriptions. Collections of these information from the population samples are said to be data collection. So actually data is what? Data is a information. If which data is the number, values which gives complete information. So if you say, if I say an example 6, whether it is data 6, so data 6 is not a data, because 6 doesn't give a complete information. If we say 6 kg, that is the data, means that it is something whose weight is 6 kg. So we, for example, we come to the board and clear how what is the data. Actually, actual data is a complete information. If we write 6, whether it is data, this is not data. This doesn't give a complete information. So this is no data. If we say 6 kg, this is data. Because 6 kg is, there is something whose weight is 6 kg. So this is the data, 6 is not data. And data is collected from the population or sample. So first, what is the population? Population is a collection of entire unit which is under study. If we and the entire collection of units is known as population. Suppose we want to study and we want to know the average height of the student of Integral University. So all the students of Integral University is our population. Now the sample is a part or subset of the population, a part and a portion of the population taken through a valid statistical procedure for analysis. So actually population is the entire collection of unit and sample is the part of the population, a small part of the population, that is the sample. So here see this example figure, this is the entire collections of the unit that is known as the population, and if this entire collection of unit we take a small part of this population, this small part of the population is known as the sample. If we study this population and find some function from this population, this function is known as parameter. That is, the parameter is the function of the population. And if we study the sample and find some function of from this sample, so this function of this sample is known as statistic, not statistics, statistic. So statistic is the function of the sample and parameter is used for the population. So this depiction is, this is the population, entire collections, and if we take some unit from this population, so this collection, this a small part of the population is known as sample. Now the next is the data, the types of the data. So first we have already discussed the data. What is the data? Data is the collections of information, and this information may be qualitative and quantitative. So data can be divided into two parts. First is qualitative data and it's also called categorical data. Second is the quantitative data and this is also known as scale data. Qualitative data is that variable, that observation that cannot be measured and counted, but its presence and absence can be observed. Similarly, the quantitative data is that data that can be observed, that can be measured and counted. Now, the qualitative data also divided into two groups. First is nominal and second is ordinal. Similarly, the quantitative data is either discrete or continuous. I will also discuss later on. Uh, so here we just take example. What is the nominal, ordinal, discrete, and continuous? So first data is divided into two parts. First categorical, that is the qualitative data. For example, qualitative data you can say honesty, healthy, intelligent, educated. So these are the qualitative data, categorical data. And the quantitative data, for example, height, weight, marks, number of students. So these are the quantitative. Now the qualitative data can also be divided into two, nominal and ordinal. For example, Nominal is used for identify the something, and this one is for here see cat and dog. So cat is represented by 1 and dog is represented by 2. So 1, number 1 is assigned to cat, 1 means for cat and 2 assigned to dog. For example, a student's roll number. Roll number is just to identify the students. So these numbers are nominal. Whereas the ordinal is, it will be as a position and rank. Here in the figure, the tallest person given the 1, the medium height given the 2, and the shortest person given the 3. So this is the on the basis of rank or position. So here in ordinal you can identify as well as magnitude. 1 is higher than 2 and 2 is higher than 3. Here you can say 1 is taller than 2 and second is taller than third person. Now the quantitative data or scale data can be classified into two ways: discrete and continuous. Discrete data, that is the count and integer as a whole number. For example, there are child, three childrens. You can count one, two, three, three children. So three is the discrete value. Next, continuous, that data or that variable that can be measurable. You can measure the height, weight, marks. So discrete value is the individual values and continuous value is a range given in the range. Now here we describe the qualitative data as they represent some characteristics and attributes. They depict a description that may be observed but cannot be computed and calculated. For example, qualitative data is intelligence, honesty, wisdom, cleanliness, healthy, literacy, creativity. So these are the qualitative data. Quantitative data that can be measured and counted. For example, so discrete and continuous. Discrete, one can only take certain values and it is countable. For example, number of students playing the sports. And continuous data can take any values. It is measurable. For example, height of the students. Now, the next, these qualitative and quantitative data can also be explained in this example. So see here the figure, a running dog, and you can get the information from this figure, and the information may be either qualitative and quantitative, discrete, continuous. So see here the which information is qualitative. So see the dog, and the information is he is brown and black. So this information is qualitative information. He has long hair. This is the qualitative. He lots of energy. This is the qualitative information. Now the quantitative information, and in quantitative information the discrete values. For example, he has four legs. So you just count the leg, and this is the individual discrete value. Four legs. He has two eyes. So this four and two is the discrete observations. Now the for continuous, if you say the weight is between 65 to 70 kg, the weight of this dog is 65 to 70 kg. So this range can take infinite values between this 65 to 70. So this is the continuous data. If you say the tall, the length of the dog is 56 to 60 centimeter. So here the 56 to 60, this is the continuous. any value between this. So there are infinite of, values in this range 56 to 60. So you can take the information like this: qualitative, quantitative, and quantitative, the discrete and continuous observation from this running down. Now the second thing in statistics, data collection, the scales of measurement. If you collect the data and this data can be measured on different scales, and this scale already I have discussed earlier, that is the nominal and ordinal, interval and scale. So these are the four different scales of measurements. First is nominal scale, which I have already shown. Nominal scale is only used to identify the variable. For example, roll number, number plate, gender, color, house number. These are the these observation, this information is measured on the nominal scale. For example, gender, male and female. So the male and female is the qualitative data. So this qualitative data cannot be directly used in statistics. So statistical data always use the numeric values. So this qualitative data is converted into numeric values. So we convert the male as a 1, a female into 2. So 1 for male and 2 for female. So here 1 and 2 is simply used to identify the gender, male and female, and nothing else. No mathematical operation can be applied on this. That is, 1 and 2 cannot be added, subtracted. So no any mathematical operation can be applied on this 1 and 2. Similarly, the color blue, yellow, red, and green. So these color also converted into numbers. So number 1 given to blue, number 2 given to yellow, red, 3 for red and 4 for green. So here 1, 2, 3, 4 is just used for identify the color, nothing else. So you cannot add 1 and 2, 2 and 3, neither you can add, not subtract, not divide and multiply. So these 1, 2, 3, 4 is always here at this time is used to identify the color. So this 1, 2, 3, 4 is simply measured on nominal scale. Similarly, the number plate, house number, and so on. So these are the example of the nominal scale. Now the second scale is ordinal. This is also this nominal and ordinal is the qualitative data. So a number which is used to identify the variable as well as its magnitude. So ordinal scale, for example, if you want to identify the rank, identify the grading, so in that case we use the ordinal scale. For example, ranking of the school students, first position, second position, third position, and so on. Here 1, 2, 3. 1 represent the student who got the maximum marks and stood first position, first rank, second and third rank. So here there are two things. First is identity and second is magnitude. 1 represent the first position, second represent the 2 represent the second position, and 3 represent the third position. As well as 1 is better than 2 and 2 is better than 3. So here magnitude is also involved in ordinal scale. 1 for first position, 2 for second, and third for 3 for third position. And you can also say 1 is better than 2 and 2 is better than 3. For another example, medical condition, better, satisfactory, poor, serious, and critical. So better is represented by 1, 1 is given, 2 for better, 2 is given to satisfactory, 3 poor, 4 serious, 5 critical. So here 1 to 3 is used for identify the medical condition as well as its magnitude. You can say 1 is better condition, 1 is better than 2, and 2 is better than 3, 3 is better than 4, and 4 is better than 5. Similarly, socio-economic status, lower class given 1, lower middle class represented by 2, middle class 3, 4, and so on. So here identity and magnitude both are used in ordinal scale. Now the third scale, interval scale, this is used for quantitative data and the data which have uh, don't have is absolute zero. A observation in which zero means zero is something. If zero is used as something, then these types of data is known as interval. In interval, you can use the identity or as well as magnitude as well as interval. For example, in Celsius, 0 degree does not mean the absence of heat. Zero temperature means there is something, temperature is something. So if 0 means something in quantitative data, then these data are measured on interval scale. And the ratio scale, this is also the quantitative scale. Ratio scale is a quantitative scale in which the observation and values can be multiplied, added, subtract. All the operations, mathematical operation can be used similarly. And here the zero is meaningful. Means zero means nothing. Zero height means no height. Zero marks means no marks. For example, ratio scale include length, weight, time, etc. So length, if you can add two length, you can subtract height, weight, you can add the time. So all the mathematical operation applied on ratio scale. You can add, subtract, and so on. Now the example, take one more example. Suppose you have collected data like this. What is your favorite subject? Math, English, science, arts, French. And these subjects are represented by numbers. Math represented by 1, English 2, 3, arts 4, French 5. So this is here 1, 2, 3, 4, 5 is just used to identify the subject. So these observations, these values are measured on nominal scale. Now the second observation, gender, male and female. Here also gender is male and female. So male is represented by 1, female is 2. So here 1 and 2, this observation is just nominal and binary because only two observation, male and female. What is your educational qualification? High school, senior secondary, graduate, PG and PhD. So here the high school is represented by 1, numeric value, SSC represented by 2, graduate represented by 3, PG 4 and PhD 5. So this is the ordinal because if someone is 5, so you can say PhD better than 4, better than 3, better than 2, better than 1. So here 1, 2, 3, 4, 5 is used to identify the educational qualification as well as their magnitude ranking because PhD is higher education, better than, higher than PG, and PG is higher than graduate, graduate is higher than SSC, and SSC is the than higher qualification than higher school. So this is the ordinal scale. So these two, nominal and ordinal, are qualitative in nature, or you can say the categorical data. This is the category. Similarly, the scale data, that is the quantitative data, score of the statistics in the final exam, score between 0 to 100. So they are infinite values from 0 to 100, and any value may be the score of the statistics in the final. So this is the scale data. You can add the two score, you can multiply the two score and get the numbers. So in a scale data, you can apply the mathematical operations. Now let's take some example. Exam marks of 60 students out of 65. So 60 student marks of the 60 student in examination is like this. So this is the raw data, or you can say this is the discrete case, individual values. The marks of the individual students are given over here. So this is the raw data and discrete observations. Now this observation can be classified and organized in such a way, group data. Here the marks is taken as the class interval 0 to 10, 10 to 20. So if you see how many marks is between 0 to 10. So if you count how many students who got the marks between 0 to 10, there are 4 students who got the marks between 0 to 10. So this observation is raw data and group data and original data. And this observation, this data can be organized in this way. And this is the group data frequency table. So the marks 0 to 10, the number of student is 4. The number of student 9 who got the marks between 10 and 20. 17 student who got the marks between 10, 20 to 30. 15 student got the marks like 30 to 40, and so on. So this raw data can be organized in group data. Now the next is sources of data collections. There are two types of sources. First is primary source of data collection, and second is secondary source of data collection. Primary source of data collection, an investigator collects the data directly from the respondent from the first time for the particular purpose. If you collect the data directly from the respondent, so this is the primary data. If you take the data from other agency, that is known secondary data. Secondary data refers the second-hand information. These are not originally collected, rather obtained from already published or unpublished sources. For example, address of the person taken from the telephone directory, information taken from the newspaper, journal, etc. These observations, these data are secondary source of data. Now the data collection method. How to collect the data? So there are different methods which is used to collect the data: observation method, interviews method, questionnaire, documents, journal, case study, group assessment, and test. So these are the different method for collecting the data. So we just explain some of them. First is observations method. This method is used to record the specific behavior, action of people and events without asking from the respondent. Unstructured observations are done spontaneously and recorded as what is seen around. So you just observe the data and write down the information. This procedure is observation data. For example, See here, you just see and count the number of cars passing the road. So here four cars or five cars are looking. So you just observe this data. There are four or five cars on a certain point of road. So this is the observation data, example of observation data. And laboratory, this is also observation. In laboratory, you collect the data using some experiment. So this is the example of collecting data by observation method. Now the second is interview method. Interview method is face-to-face telephonic conversation between two or more individuals with the sole purpose of collecting relevant information to satisfy a research purpose. So this interview method, this is the example directly from the interview method is the primary source of data collection because you are collecting data directly from the respondent. Now the next is questionnaire method. In this method, a set of questions is prepared and given to respondent. The types of question in a questionnaire, there are two type of open-ended question and closed-ended. Open-ended, in open-ended, the respondent are free to give the answer with their own choice, own language. Closed-ended, in which the options are provided to respondent. In closed-ended, also divided into two way, simple dichotomy and multiple choice. Simple dichotomy and multiple choice. So here multiple choice also determinant choice and checklist. So these are the different procedure of making the questionnaire. Questions in questionnaire. For example, the questionnaire method, you can prepare the question like this: what is your favorite subject, gender, what is your education. That these are the set of questions which is included in the questionnaire. Now come to the next. The next definition of statistics was collection of data. So we have already so far discussed the collection of data. Now the second part was classification of data. So in classification of data, we first collect the data and these collected data can be organized in such a way that it is easily understandable and systematic manner to understand. So raw data is collected in any statistical investigation are usually large and crude in form. They cannot be easily understood and are not directly fit for further analysis and interpretation. After having collected and edited the data, the next step to organize it in a systematic manner. By organization of data, we mean the classification of data in such a way that the data becomes easy and convenient to use and handle. The various authors have defined classification of data by different ways. According to R.L. Corner, classification is the process of arranging things in groups or classes according to their resemblance and affinities and giving expression to the unity of attributes that may subsist among the diversity of individuals. According to J.R. Hicks, classified and arranged facts speak themselves. Unarranged, unorganized, they are dead as mutton. So these are the definition given by different authors. Here, so many definitions. Now the characteristics of the classification. Classification forms homogeneous group of data. The units having similar characteristics are placed in one class or other class. Data can be classified and organized in such a way that it is divided into either homogeneous group or similar groups. The basis of the classification is unity in diversity. The classification may be either real and imaginary. Now the objective of classification: to simplify the condense the large data, to present the facts in easily understandable form, to allow the comparison, to help further analysis, to eliminate unwanted data, and to prepare the tabulation. So these are the objective and some rules of classification. So here just come to the types of classification. Classification can be done by the following ways. So here classification is done on four ways. First is geographical classification, chronological classification, qualitative classification, and quantitative classification. So actually the data can be classified into four ways. First is geographical, that is the on the basis of region, area. Chronological data on the basis of time. Qualitative data on the basis of characters, attributes, and quantitative data on the basis of its magnitude. So, if we have already collected the data, and this data can be classified, organized in such a way that region-wise data. For example, the classification is based on the geographical region at the same point of time. Here example, sales of the company region-wise. There are four regions: north, south, east, west, and the sale 285 sale has been taken place in north, 300 sales has been taken in south, 185 is taken east, and 235 west. So these sales, these data are classified into four region wise. So this example is geographical classification because data is on the basis of region wise. And this is the example of geographical classification. Next is chronological classification. Chronological classification is mainly based on the time. So one variable is always time, and here in this example, the time is as a monthly sales reported by the departmental store. Here the sales is taken as a different point of time in January, February, March, and April. In January, total number of sales is 22. In February, total number of, so these sales, the data of sales is organized on the basis of month. So this type of organization, type of classification is known as chronological classification. Now the qualitative classification. Classification is based on some attributes, quality, characteristics which are observed by their presence or absence. Because qualitative data can never be measured. It is either its presence or absence. Example, sex, literacy, education, these all are the categorical data. So it may be classified as a simple and manifold. So see how to classify a qualitative data. Simple classification of qualitative data. Simple classification we only divide in two ways. For example, we have a population. Now the population is divided in gender, male and female. So this is the simple classification of qualitative data. Only two class. The whole population is divided only two class. So this is the simple classification. The next is manifold classification. If the data is classified more than one attributes at a time. For example, we have the population. Now this population is divided in different class. First, population is divided into gender, that is male and female. Again, this male is divided into literacy, either literate or illiterate, literate male, illiterate male. Similarly, the literacy is all again divided into employment. How many literate are employed? How many literate are unemployed? Similarly, female, literate, and illiterate. Again, this is so we classified more and more attributes. This is manifold classification. So this type of organization of the data is known as manifold classification. Now the next classification is quantitative, and we know that quantitative is the measurable data. For example, age, marks, income, production, sales, and these quantitative phenomena under study are known as variable. So we already know the continuous variable and discrete variable. The individual values is discrete and the variable is given in the range is known as the continuous. For example, continuous variable classification. Here the monthly income of the employees of a company is classified as monthly income. So income is given in range 0 to 10,000, 10 to 20, 20 to 1000. So entire income is divided into different class 0 to 10, 10 to 20, 20 to 30, 30 to 40, and the number of employees corresponding is so six employees. The income of these six employees is between 0 to 10,000. There are eight employees whose income is 10 to 20. There are 12 employees whose income between 20 to 30,000 and so on. So here the income, this is the variable, quantitative variable income, and this income is divided into different class, and you can say class interval 0 to 10, 10 to 20, 20 to 30, and so on. So this is the continuous variable classification. Here the variable is income, and income is the continuous variable. Now the discrete variable, the height of the person is classified as follows. Here the height is given in individual values 153 centimeter. It is the individual height. 154, it is the individual value. So this is the discrete. If the height is given in range, then this become continuous. But in that case, height is given in individual values 153, 154. It is the individual values, discrete value. So this is the discrete case. So there are 7% whose height is 153 centimeter. There are 11 persons whose height is 154 centimeter. 12 persons whose height is 155 and so on. So here the height is given in discrete case. And the last slide, Income is given in continuous. So this is the continuous case, and this is the discrete values, individual values. The next, after the classification, the next is how to present the data, presentation of data. Once the data has been classified and organized in such a way that it becomes easily readable and interpretable, that is the converted into information. Presenting data effectively and efficiently is an art. It is a good idea to present data as table, chart, and diagram. So data can be represented in tables, chart, and diagram. Most people find the picture much more helpful than the numbers. In that sense, in their opinion, they present data more meaningfully. So data can be presented in different ways. Types of presentation, data can be presented by the following ways: textual presentation, tabular presentation, and graphical presentation. Generally, there are three types of presentation. Here we are discussing. First is textual, tabular, and graphical. So see what is the textual. Textual presentation. If the data size is small, so it can be presented in paragraph form. It is a combination of text and figures. It is used to explain result and trends and provide text contextual information. For example, in textual presentation, data can be presented in text form. For example, if we write one on inspection of the universities, the following complaints were noted: 27 for lack of books in the library, 20 for lack of laboratory equipments, 70 for not well maintained university buildings. So these are the information related to inspection of the university, and this information is given in text form. So data, because here the information is short, very little data, so this can be written as a textual form. Now the next is tabular presentation. The data presented in row and columns. Each row and columns has an attributes. In tabular form, we present the data in table form and all table either row and column wise, and each row and column has an attributes or variable. It is designed to simplify the presentation and to facilitate quick comparison. A table shows all data at once in a precise way. A table may include totals and percentage also. The tabular presentation has following forms: arrays, simple table, and multiple table. Now see some example of tabular presentation. This is the arrays. An array is the matrix of row and columns of numbers which have been arranged in some order. So similarly, if we have a single observation and this data has been arranged in either increasing or decreasing order in the matrix form, then it will give more and more information related to data. So the example of arrays, here this is the example. If we have the, suppose this is the marks of 25 students, and these marks has been arranged in increasing order. So you see here, first observation is the minimum marks 9, 3, 8, 9, and this is the increasing, and these marks given in the tabular form and matrix form row wise. So from this table we can get some information like First of all, the total number of observation, you just see the matrix is 5 by 5. So there is total observation is 25. The first observation is obviously the minimum observation. The minimum marks is 3. The last observation will be the maximum. So maximum marks is 66. Mod, which is the highest frequency. So which number is repeated maximum time? So here 20, 20, 20. 20 is repeated 3 times. So we can say the mod is 20. And the middlemost value in all the observation, the middle value is 24. So we can say the median of this observation is 24. So if we have a small data and single observation, a single variable observation, and arrange this observation into a matrix form, so we can obtain these information. So this process is known as arrays representation of the observation. Now the next is simple table, tabular form. Tabular form, next is simple table. Simple table presents only one variable, distribution of the age of the student like this. This is the age with their frequency, age of the student. So here we organized the data in frequency form. So one first column we have age of the students, and the second column is the frequency. Means there are 14 students whose age is 19. There are 23 students whose age is 20. So there are total 400 students, and these 400 age of these 400 students is presented in this form. And we can also calculate the relative frequency from this table. We just take total student 400, and the age of student 19 is 14 student. So just divide 14 divided by 400, and you will get this value, relative frequency. 23 divided by 400, so you will get the corresponding relative frequency of the student whose age is 20. The next is compound table presentation. In compound table, if we have more than one variable, so one variable is row wise and another is column wise. So here is the data of the result of the different courses, different programs. So here in column wise we have the programs BA, BCom, BSc, and the row wise the result is as a pass, supplementary, and fail. So here 38 students of BA who got pass, 5 students of BA who get supplementary, and 11 fail. Similarly, from the BCom program, 30 pass, 10 supplementary, and 8 fail. BSc, 33 pass, 4 supplementary, and 15 fails. So this is the two way of representation of data and known as the compound table, in which there are two variables. One is program and second is their results. So program and result, if the data can be represented like this. Now the next is graphical presentation. This is very popular presentation. Graphical presentation. Graph simplify complex information by using the image and emphasizing the data pattern or trend. It is also useful to summarizing, explaining, and exploring the quantitative data. It may be effective for presenting the large amount of data. It includes line graph, bar chart, histogram, pie chart, frequency polygon, a scatter diagram, and box plot, etc. So there are different types of graphical presentation. First is single line graph. Here there are two axes, x-axis and y-axis. Now we take the time and the population. Population of, so this is the population of a village. So at the time is given in year 1981. The population of that village is 6,000. So we just take the corresponding point. In 1991, the population of the same village is 8,000. So this point in 2001, 7 to this point and corresponding to this point. Now we connect these points by a line. So this is known as line graph. So here just we see this graph and we can say the what is the population trend. You can say from this that the population in 1981 is 6,000. Then this population is increased in 1991, again decreased, then increased. So this is the trend of the population of the village. And this representation is single line graph. Similar, the multiple line graph, like this, there are two lines, one given in blue and second is in red color. So there are two variables. One is, in this example, you see the graph display the information on several variables so that the comparison is possible between them. Here the growth of Lisa's collection, number of books. So here the number of books and number of music CDs. The data is given in month wise. The January, in January, the total number of collections of books, and this in blue line, this is the music CDs. So music CDs is higher than collection of book. In February, this is also music collection is higher than book. March, this is close. April, this is again higher, and in May, this trend go down, and in May the books collection is higher than music CD. So here this data shows the collections of books and collections of music CDs, and you can plot this data on the graph and you can compare also. So here multiple graph, you can also take 3 and 4 lines, whatever you have variables. So this is the example of only two variables. One is number of collections of books and collections of music CDs. Now the next example is simple bar chart. Simple bar chart is always used for categorical data, that is the qualitative data. If you have the qualitative data or categorical data, then use always simple bar chart. Okay, so here also we have two axes, x-axis and y-axis. On the x-axis, here x-axis the student grades. There are four grades: A, B, C, D, and on y-axis the number of students. So if you see, this is the bar, and A, B, C, D is nothing but the ordinal scale data, because this is the grade of the student. A grade, there are 4 students who got a grade A. There are 12 students who got grade B, 10 students who got grade C, and 2 students at the grade D grade. So here ABCD is the qualitative variable. So always use bar chart for qualitative or categorical data. If you have a categorical data, then you should use bar chart. Now the next example, multiple bar chart. This chart represents multiple categories of data. Bar chart, this is also used for categorical data. Now you see on x-axis, this is the program courses, and y-axis the results. And you see the program. There are three programs: BA, BCom, and BSc, and there are three bars. One for pass students, second is supplementary, and third is for the fail students. So from this bar you can say the pass student for BS is more than 35. This is more than 35. I think it is earlier slides. It was like 37 or 38 students of BA who pass. So this tabular form can be presented in the multiple bar diagram like this. BCom, this is the three bar, one for pass, second is supplementary, and this is the fail. For BSc also, this is for pass student, this is the supplementary student, and this is for the fail student. So here, without using table and without writing any of the data, you can just see the bar and you can observe what is the data. So this is the representation of multiple bar chart. The next is histogram. Histogram always used for the quantitative data, and in quantitative, that is the for continuous variable. So if you have the continuous variable, then always use the histogram. This is also two axis, x axis and y axis. In this example, on x axis the age group of the workers, on y axis number of workers, frequency. So the age group, the age is divided into class interval, that is 20.5 to 25.5, 25.5 to 30.5. So this is the range of the age group. And on y-axis the number of workers. You can say 5 workers whose age is between 20.5 to 25.5. There are 12 or 13 workers whose age is between 25 to 5 to 30.5, so and so on. So this is the representation of the quantitative data. If the quantitative data is given in the continuous range, so histogram is always used for the continuous variable. On x-axis you take variable, and y-axis you take just frequency. Now the frequency polygon. This is also one of the representation of the data, and frequency polygon is nothing but is the second part of the histogram. After making histogram, you just point the midpoint of each histogram on y-axis. So middle point of the each rectangle, and all the middle point of the rectangle is connected with the straight line. So first, see here on x-axis, first rectangle from 0 to 20, next is 20 to 40. So 0 to 40, 20, the middle point is 10, and this point. So 20 to 40, middle point, this. So all middle point of the rectangle of the histogram is connected with a straight line. So this straight line is known as polygon. This is the black share line. This known as polygon. Now the next is pie chart. Pie chart is also used if the data is distributed. If you have a complete data and that can be distributed among other activity expenses. For example, you have the amount 15,000 and this amount is distributed among different rent, grocery, transport, current, school fee. So this is the obviously this is the nominal scale data, categorical data, and this data can be represented by the pie chart. A pie chart is the nothing but a circular graph that displays the relative figure, and in the bar chart you just take a center, and from the center you have to take the radius, and this can be divided into either percentage or degree. So just sum up all the distributions and the total is 15,000. So just divide 7,000 divided by 15,000. If you want to show in percentage, then multiply it by 100. If you want to show it into degree, then multiply it by 360. So here 7,000 divided by 15,000 multiplied by 100. This is the rent, and rent is 47%. So this area from the center, this is the 47% of the total. This area represent the rent, expenses on rent. This is the 13% saving. This area represent the 13% of the total for saving and so on. So this can be calculated simply the total 15,000 divided by the individual expenses and multiplied by either 100 or 360 degree. Okay. Now the last presentation of data is box plot. This is the 5 number summary that includes the minimum observation, first quartile, median, third quartile, and maximum observation. If you have the data and the data is divided, first observation is the minimum arranged in, if the observation arranged in either increasing or decreasing order, then the first observation is minimum observation and the last observation will be the maximum observation, and the middle most value will be the median. So here the yellow color shows the median, middle value, and the 25% of the observation from the below is called the first quartile, and 25% observation from above side, that is the known as third quartile. So here this show the 25% observation, this is show the 25% observation third quartile, and the center is the median, and the range from the first quartile to third quartile, this is known as interquartile change. So if the median is, so if the median here, median shows between the observation, and i- from the median the range is taken as a first quartile, and the above side the third quartile. These of the this is the 25% observation, and this is the 25% observation below. So this will use after studying the mean median mode. So this is just showing this slide, and this is, I think this is the last of the presentation of the data, the box plot, and Next time we will start the next that is the analysis of the data. So here we stop, and so far we have already discussed the collections of data, classification of data, and this last one is the presentation of data. So now stop here, and if you have any query, any question, then you can ask. Okay, thank you. Any questions? Any question from audience? No.